All right, greetings everybody. Welcome to the 2-2 Concept Guide. We're going to talk about properties from algebra and providing reasons. I hope you don't get distracted by my B3 class who's out here right now with me.
Hi!
All right, yeah, we're going to be talking about these properties: addition, subtraction, multiplication, division, the reflexive and substitution properties. Oh, hopefully I didn't distract you too. And how, well, we're going to use them as reasons for things. So here, let's start with this. Given that x equals 7, why does x plus 3 equal 10? Because, well, what happens there? Well, 3 got added to both sides of the equation. So we will be able to justify this happening because of addition. Adding 3 to both sides is what happened. If you look at number 2, I got n is equal to 6. What happened to the n and the 6 to make the 2n and the 12? It got multiplied by 2, so that's called multiplication. Right? Number 3, the measure of angle A plus 20 equals 60 becomes measure of angle 20 equals 40. Well, what happened here? The 20 went away, 60 became 40. That's because we subtracted 20. And then number 4, both sides are being divided by 6. 6 times DE equals 18, so then DE equals 3 when we divide both sides by 6. So that's division, all right? Now, there's another way that we need to be looking for the addition property. If A equals 7 and B equals 10, then A plus B will equal 7 plus 10, or 17. But I'm going to take these things that were equal and these things that were equal, add the first parts together, and then add the second part together. And so A plus B equals 7 plus 10, or of course 7 plus 10 is 17. Or what if it looked like this? The length of AB equals the length of DE, and the length of BC equals the length of ED. Then AB plus BC will equal ED plus BC. So I'm really following this pattern here. AB and BC were the first items, and DE and ED were the second items. There's a problem here. Hold on. There, my bad. Yeah, AB plus BC what it equals, yeah, I got myself confused. Equals, yes, DE plus ED. The left, AB plus BE, the left sides of these equations equals the right side of these equations. I'm adding these things that are equal plus these things that are equal. I did a terrible job of explaining that. I'll try to get in class, but hopefully that helped. All right, next, the reflexive property. Write this down. The reflexive property is when something equals itself. And if you're paying attention right now, write next to it like a mirror, like a reflection. But so very simply here, measure of angle PDF equals measure angle PDF. It's itself. MN equals MN, et cetera, et cetera. When something equals itself, that's simply called the reflexive property. Substitution. Substitution is where when one thing is equal to another and then that other thing is equal to something else, well, this angle C can take the place of that angle B because they're equal. It can substitute. So angle A also equals angle C via angle B. Here's another way that we will see this. If the length of DE plus EF equals DF and KL plus LM equals KM, and then there's another statement that says that these two things are equal. DE plus EF equals KL plus LM. Okay, this got here, and then this got here. So as a result, the DF can take the place of the DE plus EF, and the KM can take the place of the KL plus LM. It's like a double substitution. It's like in a football game where two people go in for at the same time. Right. Then the segment addition postulate is something we already know about. B is between A and C. Well, okay, there's not a diagram, so draw the diagram, okay? So B is between A and C. It doesn't really matter where it is on there. This concept won't change. So AB is this part of it. BC is this part of it. And what we learned with the segment addition postulate is that when there's a point in between, we can add these things together. AB plus BC equals AC, and the part plus part equals a whole. We call that, when they're segments, the segment addition postulate. The angle addition postulate is the same, it's just we're talking about angles. If A is in the interior of angle BCD, so A is just somewhere in between, in the midst of angle BCD, well then there's also these, that creates these two other angles, the parts. Angle BCA is a part, angle ACD is a part, and we put them together, we get the whole angle BCD, and that's the angle addition postulate, where one smaller angle plus another angle that's adjacent to it make a bigger angle. Okay, so those are things that we will see. Three more things that we've seen are, one is a midpoint. So let me move this over. If T is the midpoint of segment MP, well, there's a diagram. You can draw one over there. That's an easy one to draw. Then, well, a midpoint makes two congruent segments, so MT equals TP. We could also write it this way. We could say that the segment MT is congruent with segment TP. That can also be said for the same reason. And we would call that the definition of a midpoint. That's what a midpoint does. A segment bisector makes a midpoint. So if AB bisects segment MP at point T, so this thing bisects an angle, it's a segment, bisects a segment MP, it's a segment bisector, that makes T a midpoint of segment MP, which they call the definition of a segment bisector. And then when we have a midpoint, we can do what we just did above and say MT equals TP because the definition of the midpoint. So a segment bisector allows us to make this conclusion, which then leads to the next conclusion. An angle bisector is like a midpoint for angles. It makes two congruent angles. So if this ray bisects this angle, the ray bisects the angle, then we end up with two congruent angles, because that's the definition of an angle bisector. All right, so all of these things that we've just put together, starting at addition all the way down to the angle bisector, we have a set of reasons that we can justify things. And that leads us to these things called these proofs. Now, it's going to take us a while before we're doing these, but what we start doing here in this unit is filling in these reasons here. So the way these things work is you're given a diagram, you're given some information about the diagram, and at the very end we want to be able to say that this is true. So this thing starts out by saying that measure angle 1 equals measure angle 3. Why do we know that is a fact? Well, because they told us it's a fact. So, and when I write it in here, I want to mark my diagram. That angle is congruent to that angle. Why? Given. It was given to us. Now, why can we say for that angle, measure angle 2 equals measure angle 2? Well, that's like the mirror. That's the reflexive property. From there, how can measure angle 1 plus measure angle 2 equal measure angle 3 plus measure angle 2? Well, I'm adding basically line 1 and line 2 together. That's angle 1 plus angle 2 equals angle 3 plus angle 2. That's called addition. Now, measure angle DEG is this guy over here. How is it related to angle 1 plus angle 2, like this line says? Well, that's angle 1 and angle 2 are the two parts. What do we call it when the two angle parts add together to equal a whole? Angle addition postulate. And the very last line of a proof will look like this. Whatever you're trying to prove, it's going to go down here in the last line. The given's going to start at the top. The proof is going to come down here at the bottom, what you're trying to prove. The reason is not proved, but why is this true? Well, measure angle 1 plus measure angle 2 takes the place of DEG. And sorry, DEG takes the place of angle 1 plus angle 2. And HEF takes the place of angle 3 plus angle 2. And that's called substitution. This is an introduction. Don't get too stressed out about this. Let's finish this up. In this given down here, B is the midpoint of segment AC, and C is the midpoint of segment BD. We want to prove that AB, this segment, equals this segment. Well, here's how we'll do it. Because they're both midpoints, I get to make these conclusions. AB is equal to BC. That's because B is the midpoint of AC. And BC is equal to CD. That's the definition of the midpoint. I get to make both of those conclusions because of both of these givens. And then AB is equal to BC, and then so is CD. So the CD is going to take the place of BC, and that final reason is substitution. These are some examples of what we'll be doing. We'll be certainly working a lot on it in the days to come. But hopefully that was a little bit helpful. We'll work on it. Get some rest. Bye.